work uh, as much as you can, right? To stay on top of things. Okay, here we go. Page 23, Intro to Cosine Law. I'm gonna have a red pen on this one. So no highlighter. I'm just gonna have a red pen for this one. Or anything that sticks out. One color that sticks out as you write. Okay. So recall AAS, ASA, and SSA. You're like, what is that again? Those were like the cases where sine law works, okay? In every single one of these scenarios, watch this, folks, this is what you need to focus on. What will you have every time when it's sine law? You will have a pair. Not like a pear as in like a fruit, okay? I know you're hungry, but a pair like that, you'll have a side angle pair. And that's when we knew we had to use sine law. Okay, we had to use sine law. 3 cases where sine law is applicable. Okay, 3 cases. Cosine law can only help you in 2 cases. They're very particular, they're hard to miss. So I tell my students, either look for a pair as much as you can. If you can't find a pair, it's probably cosine law. Well, I should say it's definitely cosine law. If you can't use sine law, it's definitely cosine law. So here are the 2 cases. SSS, that just means, guess what? You will know all 3 sides. It doesn't matter what the triangle looks like. If you have the measurements of all 3 sides, definitely cosine law. You can put money down. SAS, what I want you to focus on SAS is that the angle, okay, angle between sides. That is what SAS should try. That's what I want you to get from SAS. So, you ready? It'll look like this. You will know one angle, and you will know the sides that are surrounded. So it's almost like a sandwich, right? SAS. So the angle is sandwiched between the 2 sides. And so I'm going to give you one more scenario here. Let's say you know this obtuse angle here. Then you would know both sides here. You know that it's an SAS. No pair. If you think about it, there are no pairs, right? If it's side, 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 no pair, correct? Because there's not a single angle, so there's no pair. Over here, there is an angle, but it's not across any of the sides. It's in between the sides, so you're stuck, okay? Maybe I should tell you this. You think you can solve an angle that has, a triangle that has angle, angle, angle? All angles? You can't solve that one. That one is impossible to solve. You need at least one side length to get you to figure out the rest, okay? So if I ever give you an angle, 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 you can you can write big, can't be solved. What are you doing this, Mr. Erickson? So if that ever happens, don't worry about it. So I'm going to split this into 2 cases, okay? In these cases, you do not have a pair, which means you need to use cosine law. The SAS case, right? The 2 sides with the angle sandwiched in between. Here you go, guys. This is the first version of the formula. Let's say you know this side and you know that side, as well as the angle sandwiched in between. First of all, you'd be like, oh, SAS, cosine law, right? But on your study sheet, you probably want to have the SAS case and then the following formula written down. Got it? When you have SAS, cosine allows you to solve for the angle, side opposite to it, this side right here. So this is how it goes, and that's why I use my red pen to get me started. I'm going to start way over on the left here because it's a long formula, okay? X squared is equal to the other two sides squared and added. It doesn't matter which order, but we're going to go c squared plus y squared. Hey, this is Pythagorean theorem. Not so fast, right? It's going to change. You ready for this? Minus 2 times c. And I do this in the order. What was the first side I squared? C, right? So I make sure that shows up first. And then the second side was y, right? Shows up second. All of that multiplied by cosine of angle capital X. And I use red here because then you see, oh, because I have angle X, I have this angle right here, I will be able to solve for the side length that's across from it. All of these numbers on this right side, you should know what they are. Okay, so it's all going to be about plugging it in and just making sure you crunch them correctly, okay, or else you'll be in trouble. This is what I, honestly, under SAS, this is what I would have. That's it. So you will have sine law, boom, right? And you'll have cosine law, SAS, specifically to SAS. Okay, this is the one. This is the formula. But let's write them. Let's for a second imagine you got to pay attention here, right? SAS. Like let's say you knew these three on this corner. That would allow you to solve for side C, correct? So you could rewrite this in the following way. C squared is equal to, what are the other sides other than C? X and Y, correct? X and Y. So you would go x squared plus y squared minus, how does it go? 2 times, earlier we had C here, right? We use C there. There's X there, X here. Times Y times cosine of what? Yeah, cosine of C. So the angle opposite to that side. There we go. Let's do it one more time. Let's say you knew the 3 up here. You knew this side, that angle, and this side, which would allow you to solve for side Y. So you would start your formula like that. Okay, what are the other two sides? It would be C and X, right? So C squared plus X squared minus 2 times C times X times cosine of Y. Fun stuff, right? I know. Well, really, you just need one formula. These are just different versions of that exact same formula. How would you use it differently if you knew different sides? This is just to recognize the pattern. That's all. Okay? And just remember, you got to make sure you understand this is minus 2 times this times this times this. So these are all multiplying at the end here. Don't dread it. Your calculators are awesome for this. It's honestly not going to be a problem at all. Next, what if it's a side-side-side case? Yes. Side-side-side. When solving, watch what it says here. When solving for a side-side-side triangle, start with the largest angle, more later. So I'm going to just highlight that. If I ask you to solve for a triangle, start with the largest angle, please. Otherwise, you're going to have an issue later on. All right. So if you have side, 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 that means that these three sides will actually have a number attached to them. Okay? By observation, which one is the largest angle right now? C, correct? Let's do that one first. So this is how it goes. It's a variation of the first one I just gave you. It's just doing a bit of algebra to move stuff around. So watch this. Cosine of angle C, so you can't just start with C, okay, is equal to, this is what I'm going to ask you to do, okay? You make a long line, it's going to be a division here. Something like that. And there's going to be two things added and one subtracted, always, plus, minus, like that. And the first side I'm always going to ask you to write down is the last one here, which is going to be C squared subtracted. That's why I use my red pen again. And then you use the other two sides, which is in this case x and y. So x squared plus y squared minus c squared. And underneath it's divided by 2 times x times y. So side C should only show up once at the end here if you're trying to solve for angle C. So I'm going to box this in and say this is it. Okay, but we're going to take the time to rewrite it in the other formats. So real quick here, if you wanted to, because technically if you have all three sides, you have a choice which angle you want to solve for first. You can pick any one if I don't specify. So let's say you wanted to solve for angle x, you would go cosine of x is equal to, I'm going to go a little faster now, okay? Long line plus minus, I'm going to make sure side x is at the end here. Remember, they're always squared. Don't forget the squaring on the top here. So if x squared is here, the only other two sides would be c and y that I can use now. C squared, y squared, and then it's 2 times c times y. Boom, you're done. See the pattern, right? For example, the first version, these two numbers that you put here, they show up again down here. Same here. These two numbers show up again down here. Okay. Last one, cosine of angle y. We will make that long line. We're going to go plus minus. Which side goes at the end? Y. And then it's I used y, so I need to use c and x. So c squared, x squared. 2 times c times x. Voila, you're done. I need you to highlight this one. Sorry, I'm going to go up a little bit. This box up here. You notice this box, it's very important for cosine law. What does it say? A negative numerator indicates that the angle will be obtuse. So basically, whenever you're trying to find an angle, folks, in a triangle, so let's say this is the angle you want, there's always a supplement to that angle every single time. Cosine law distinguishes. So if the numerator is negative, right? So this would be a negative, which would be obtuse. If it's positive, it's acute. Cosine distinguishes between acute and obtuse. I will zoom into that so you can see it better. And I'll box this in. Cosine distinguishes between acute and obtuse. Sine law doesn't. Sine law never doesn't know the difference. That's why chapter 4 comes in later. But don't worry about it too much now. Cosine law, however, you should realize, oh, it's a negative numerator. I'm going to have myself an obtuse angle. All right. We're good? 25. SAS example. It says solve for side P. Part B says solve for angle R and angle Q. Hey, calculate the height of the triangle. We talked about that today, but we'll do that at the end. Don't worry about it just yet. Let's do part A here. It's going to be completely filled in by the end of today's class, so make sure you use the space wisely. Do you have a pair? You're like, okay, I'm going to look at my cheat sheet. What is this? This is SAS, right? I don't know if you recognize it. This is SAS. I have to use cosine law. So now you're going to have to start distinguishing which law am I going to even use. There's only one. There's only one that gets you started. Later on, you can switch over if you like the other one more. But here we go. To solve for side P, I need to start, I'm going to start with my formula because we're still new to this, okay? I would have to go R squared plus Q squared minus 2 times R times Q times cosine of angle Q. Don't forget about the P squared. It stays squared until we square root it, okay? There we go. R, what's that? P is unknown, so that one is here. So, oh yes, sorry. Good catch. This is not supposed to be Q. It's supposed to be P, yes, my bad. Thank you. Almost. R squared, so this is R squared, no decimals here, so you're welcome. Okay? We square that, we go minus 2 times 5 times 8 times cosine of 70. And watch what I do. You take the root of both sides, so technically you're left with P, and I already start my root on the other side like that. I'm going to figure out what that is and plug it into that root. So grab your calculator. It's actually very easy. You can type it in all in one shot. That's the beauty of using these calculators. So I'm just going to go 5x2 plus 8x2 minus 2 times 5 times 8 times cosine of 70. And I hope you set all your calculators to degrees. We did that on Tuesday, right? I hit enter, and I get that. 61,638. So I'm just going to write that down. But I'm not going to round, okay? So I leave that on my calculator. I go, this is the annoying part. I can't believe that a calculator doesn't have a square root button just like that. But second, x2 takes the square root, copy, paste. And so it's 7.85. And we are in centimeters. You may omit that very first line that I did in the future. So technically in 3 lines, you can have this answered. Done, right? You got it. Does this make sense? I don't know actually right now because I only have one angle. So right now you just have to kind of trust your answer. B. two things are happening now. Do we have a pair now? Could we use sine law? Will I use sine law? No. I'm going to pretend like I don't know the sine law right now. Okay? Did this turn into a side, side, side now? Yeah. So we'll say we now have a side, side, side case. And I won't make note that we have a pair. I'll just ignore it for now. So could you please, we're going to copy that down, that top triangle. I'm just going to ask you to make a triangle real quick. So I'm going to go P, Q, R. After this, we're done, okay? I just want to make sure we have two examples here. P, Q, R. We know this is 70. We know this is 5. This is 8. And this is what? 7.85. Hence the side, side, side. So I'm going to go check, check, check. Side, 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 right? It's asking me to solve for angles R and Q, all right? This one and this one. Which one is the largest angle, do you think? It's going to be Q because it's across the longest side, all right? I'm just going to go ahead and solve for that one. So watch what I would do here. I would go cosine of that angle. So you would go to your study sheet, obviously. And so maybe that's your homework as well. Add that to your study sheet. Plus, minus. Sometimes it's going to backfire a bit. You're going to have to spread them apart a bit more. But what goes down back here, guys? Q, yeah, this one has to go first. So I'm actually going to go a minus Q squared. And the other two are P and R, correct? So we're going to go P squared, R squared, like that. And then it's 2 times P times R, like that. That's how I will be able to solve for angle Q. So cosine of Q is 7.85 squared plus 5 squared minus 8 squared over 2 times 7.85 times 5. And here's where we're going to do a bit of a choo-choo train. I don't like trains, but we're going to have to do with it. Okay, otherwise you're going to take up too much space. So here's where you cannot, I would not recommend you doing this in one shot. Grab your calculators. And you type in the top first. So 7.85 squared plus 5 squared minus 8 squared. And you write that number down. All decimals, please. Well, you don't have to write down all decimals, but I expect you to use all decimals. Then you do the denominator. 2 times 7.85 times 5. That's 78.5. Another choo-choo train, sorry. So I'm saying I'm simplifying this, turns out to this, and now we're going to divide these two. That divided by 78.5, and that is 0.2881, and that keeps going. And remember, what did we do before? As soon as you start saying Q, angle Q, you're gonna, what's gonna show up on this side? Cosine inverse, yes. Of 0.2881. So I'm going to go second cos. Make sure you don't mix up sine and cosine. Sometimes students do inverse sine. I get it. It happens, right? But try to avoid it. So you take the inverse of that, you get 73.25 degrees. Hold it, I never talked about it. Was the numerator positive? The numerator was positive, correct? So I expected an acute angle. So maybe I'll just make a note here, almost like bubbles. Positive, therefore acute. Right? As soon as you know this is positive, okay, it's going to be acute. Guaranteed. You can put $1,000 down every time. Okay? Make a bet with your friends. Don't do that, actually. He's encouraging gambling. So angle R is 180. Oh, wait. You get this part, right? I already have two angles. I won't do cosine law again. You could if you like cosine law so much and you have time. For sure, you go for it. But I'm going to solve it like this. So angle R ends up being 36.75 degrees. You now solved. They need to give you three things to start, folks. And you find the other three. That's what you call solving a triangle. And we did. We found the one missing side and the two remaining angles. If you don't know, if you want to make a note, sum of triangles equal to 180 here, I don't require that. I would know that that's what you did, but leave it like that. We're not done yet. One last thing. Calculate the height of the triangle. How do you do that? I'm going to go up here. I hope you still have some space somewhere up on the side here. My hope is that you have a little box here. This is C. What's the height? Do we have a slant? Yeah, we actually know this slant and this slant, but I'm going to use the one that I was provided with. And we do know the angle that's touching it. So to find the height, honestly, it's just 5 centimeters times sine of 70 degrees. And that is 4.70 centimeters. That is, if you'd like, that's this thing here, right? If you like highlighting, if that is, it's helping you, I'm just going to show you that that is this, and this number comes from right there. And it has to be sine, though you can't go cosine law, right? So for height, it's exclusive to sine law, if you want to use the shortcut. Okay. I'm going to ask you to try 26 to 28. It's not on there, is it? 26 to 28. Do at least half of them.